is up? We have a 2014 GMC Sierra 1500 in for a lot of stuff. So obviously looks really good. Stance is pretty well dialed on it. It's lifted and it's on 35s. It's got the 5.3 6L80. The 6L80 slipping real bad. I tried to service it and it just didn't get any better. So we are going to put a different transmission in it. Beyond just the transmission, we might as well make the power that this new transmission is going to hold. This transmission's a 650 horsepower deal. So we're doing a turbo. I'll go through the kit that I kind of put together for it. It's a combination of a lot of stuff that's just out there on the market, but I think that I put together a pretty good medium kit that's going to leave a bunch of headroom and kind of overkill parts. Stuff that you don't really need, but it'll be nice to have. So it's not a budget build by any means, but it is going to be a street-friendly build. Camshaft I got is pretty small. It is so it'll have a way bigger fuel lobe and everything. We should be able to just use the stock injectors and what we have and still make plenty of power, have plenty of fuel overhead. We're also going to go we're going to switch it from a pulse width modulated fuel pump back here to a just a Hellcat fuel pump turned on with a relay. We're just going to use the PCM to trigger the relay, and it'll just go to its own regulator return system and go into the stock fuel rails from there. So it should be plenty of fuel for a turbo. Instead of doing a small turbo, we're actually going with kind of a laggy one. It's a GT45, but it's the upgraded version of it with the better metallurgy, the better turbine housing, can handle a lot more heat. And it also has a special what do they call those? A billet compressor wheel. It's supposed to work better than most of those that come out of China. So it'll be kind of the small on the compressor side, but real big on the turbine side. Real easy on the engine, not a ton of back pressure. We're not going to be pushing a ton of boost. We just want to shoot for 8 to 10 at the most, and that should just be in the sweet spot of that turbo. And for the price and quality of it, I think it was the way to go, rather than going with like a T70 or T76. Which would just have a ton of high turbine pressure, a bunch of back pressure, and it would light up real fast and feel nice. But since we're not trying to go as fast as we can from a dig and out of corners, we are just going to stay with the laggy one. I'm going to show you what we're doing here for the fuel system. I've got the tank down, got the sending unit out. This is the stock fuel pump. It's a good unit. But just to make sure that we're not going to have any fuel issues, we're going to put the Hellcat pump in. It's the TI Automotive 525 liter per hour. The other thing with these, the Gen 5 Chevy stuff, is it's all pulse width modulated fuel pressure. So instead of like a mechanism that controls the pressure as the RPMs go up and down and everything is kind of transient, it just uses an electrical pulse to speed up or slow down the pump. And it's not a bad system, but when you go turbo, sometimes you'll need more fuel than this can provide in an instant. So what we're going to do is put a return style regulator under there as well. Now I have come across information online where people have just dropped these into the basket and it works just fine with the pulse width modulation, but I just don't want to have any issues with that. So what we're going to do is use the power wire to just trigger a relay, and so this will just be pumping at 14 volts, whatever the battery voltage is, while it's running all the time, and all the extra fuel will just go back into the tank. So what I've done here to modify the basket is I've added that bulkhead there. It barely fits right in that little spot there. It's a -8, which is a 1/2 inch feed. Now there was a little piece that I'll show you that came in this that I'm just going to delete. It looks like the pump would pump into this little ring that would sit around it and fill that thing up, and then it would go into the fuel feed and out. But we're not going to use that anymore. We're just going to go, and then the regulator will return the fuel right back to the basket. No issues. The only other thing I got to do is replace this plug with this little pigtail. And I think what I'll do is I'll just cut and splice it on this side of it. And we'll plug this back in. This is the level sender that floats with the fuel as it goes. That's it, Hellcat fuel pump. And then I'll show you the wiring once I get that in. Here's that little unit I was telling you about. I'm not sure exactly what it is. It used to be in that basket. The more I look at it, the more I think it was a filter of some kind. And we are going to be running an inline 10 micron filter, which is going to be better than whatever the stock came with. They're usually like 100 micron or worse. So that's gone now. We're not going to use that anymore. So here I got it all put together. I just used the connectors that it came with. I put them right next to each other. If I would have thought about it a little more, I probably would have cut up here and down here and offset them a little. But we'll live with it. It'll just be fine. I went and checked on the harness. The power wire going in is this outside one. I'm just going to assume that means that this one was the positive. But before we get too far, I'll use a power probe and make sure that it's pumping the right way. This nipple here was a little bit smaller than I was hoping, but this went on it and held on pretty okay. And then what I did is I put the clamp on and then I heated it up real carefully. And made sure to cinch it down nice and tight, and it seems to have a real good connection now. Melted the plastic kind of into all the, doesn't feel like it's going to pull off at all. The pump side was perfect. Obviously the hose came with it, so that's good. Once it's in the tank, this kind of squishes down. It'll sit flat on the bottom. It's got the little sock down there and everything. And then, like I said, the old fuel feed is now the return. Goes right down into the bucket. Never gonna have fuel shortage. Also gonna start looking at the regulator here. Let's see what we got. This is a PQY. I've had nothing but good luck with these. There it is. Put the little adapters on it in a minute here. I think it's gonna go right here somewhere. Maybe upside down. I'll show you how that turns out later in the day. Here's our 10 micron fuel filter. I've used a few of these without issue. I used one of the cheaper paper ones on my turbo build, and it let something through, and I had an injector stick open, so I started getting these cheap. It's available on Amazon, but it seems like their products are really good. Like, I like their AN fittings and AN line and stuff. It's just like a step above getting eBay junk. So but this is like a metal cartridge that's replaceable in it, and it looks just like, if you hold up the more expensive brand name stuff like the Deechworks or AEM, looks like it's probably from the same factory. I don't know that for sure, but that's what we're going to use here. I also got started on the feed line here, so that'll go into the top of the fuel sending unit, that little bulkhead that we added. That'll tighten right down, and then I'll cut it to length once we get it in the truck, and I'll either have I have straight fittings or 90-degree fittings. We'll see what the regulator takes. Just doing some final testing of the fuel pump setup here. The new feed here, and the new return, which was the old feed line. And we've got all these connections up here. So into the regulator, out of the regulator, into the filter, out of the filter. And then what I'm going to do is connect that to the stock fuel line there. But I've just got it in this fuel tank now, so I can just check and see if anything comes out through it, make sure it's all clean. So here we go. I'm gonna just test it with the power probe. I've already got the ground pin grounded. Let's see if we can see it here. You can hear it going. So here's how the final setup went. Got the tank back up, but everything works. See if we can see here. The fuel feed barely touches the bed there. was a little nervous about it, but it's still, you can still wiggle it, so it's not a ton of pressure on it. So that fit perfectly. We've got the new feed and the new return right here. Remember, the feed goes into the regulator. I've got the regulator upside down right here. Goes into the regulator. Whatever excess fuel goes back through the return right here. Fuel goes through here into the filter. This is not permanently mounted yet. I just have it zip tied on, but we'll have to figure something out there. And then it necks down to the -6 because the 3/8 feed is what the stock setup was. So that, let's see if we can see it. 6 AN right here. I've got a quick connect fitting on it, just snaps right on. I checked everything for leaks. It's all good. I think that'll work out great. And then, since I haven't shown you this, that's the new relay that just bypasses the pulse width modulation system. What I did was get about halfway down into this and cut the power wire and used that to trigger the relay, and then I spliced the output of the relay to the other part that I caught that goes into the pump there. And then the main power wire, let's see, there's a fuse for this right there, very accessible. And then that power wire goes behind the tank along the fuel rail. You can start seeing it here, all the way up to the battery. Well, things have progressed since the fuel system. Doing the cam swap, I learned some things about these L83s, these new Gen 5 Chevys. Getting the cam sprocket off is very difficult to do in the vehicle. I think that I personally would have to drop the pan to make it happen. In order to do that, I was gonna have to do the steering rack and everything, move that all out of the way, and I figured I've already got the heads off of this thing. It's really not very many steps to just pull it all the way out, and then I can actually see what I'm doing just because I haven't done a lot of these. What I figured out is you do need to be able to move that oil pump a little bit out of the way in order to kind of finagle the little cam sprocket off. I say little, but it's huge. All this stuff is kind of part of the problem, but with the pan off, it's super easy. The oil pump just pops off. I was careful not to let the pump rotate at all, and I'll just put it back on exactly as I had it. I know that they recommend just doing a brand new one every time for whatever reason. I don't know if it's a balancing issue or if it is kind of keyed, like some of the little grooves there might be different sizes or something. I just don't know. But I'm going to attempt to just put it back on as is. I'll let you know how that went. What's the other thing here? The annoying part is everything is RTV'd on these right from the factory. They don't use gaskets anymore. And we've got O-rings like these two, and then there's one on the oil pump, which I've got right there, and it sits down in that groove there. So it's not really possible to pull the oil pump straight out without breaking that seal. So the pan's got to come down. That's just how it is. I saw some video on YouTube of a guy who picked the chain around, but it is real tight to do that, and I wasn't comfortable forcing it that hard, so I just moved on to something else. Here's the two cams, the stock one's here. It's not in bad shape. I wanted to show you this just to see the difference here. The Brian Tooley one we got, stage 1 turbo. It's really aggressive. I'm used to seeing the LS cam specs. And for an LS, that's kind of high lift for just like an everyday truck. The duration looks spot on though. This is the fuel lobe. You can see that the fuel lobe is much more mild on the stock one. This one's way more aggressive. It's supposed to be like 40% over. And you can kind of see, it's kind of hard to see on the camera actually, but even the lobes are visibly bigger. So this boy's gonna let this L83 breathe. A little more progress on the engine. For the DOD delete, I got these tower plugs. They were actually designed for it. I know a lot of people just get the bearings and take them apart and shove those down there, but these are kind of nice. They They have like a little a step at the very bottom to get them started straight, and then you just tap them right in with a ball peen. Went real good. I also used some of the green Loctite. What is this stuff called? Sleeve retainer. It's basically anything that's press fit that'll help it just stay a little better. Jammed them in there. Looks like that should work out, and then no need to have oil going through them anymore. The other thing I did is I took one of the old head bolts. I'm going to replace them all with new factory. And I cut that little groove in there and ran it down each of the head bolt holes. Got all the old Loctite and junk out of them. Sprayed some brake clean down and blew them out. We've also got the new LS7 style lifters in there. I got the GM ones. They've been kind of hit or miss for a few years, but the last 2 sets that I've used have been flawless, so I'm pretty confident with them. And brand new trays to retain them. So we got rid of the DOD lifters there. No more. That is the Achilles heel of these GM engines. Anyway, it's looking good. I sprayed down each of the cylinders with WD-40 just because it'll be sitting open for a day or two. One of the issues that I ran into that I didn't even think about until today, while I had all this stuff, I was like, maybe I should make sure I know where the oil drain's gonna go. So I looked at the kit. It came with this style instead of an AN drain. There's an adapter and everything for it, but the hose is this long, that doesn't go anywhere. And so I'm gonna take matters into my own hands since I have the pan off already. These Gen 5, a lot of, on the LS's, I use the oil level sensor hole and just put there's a real cheap adapter. You can just put an AN fitting on it and drain it to there. This one is a little odd. You pop it off with this C-clip and it just pops in. And I'll end up just removing that whole thing. It's this whole assembly right here, if this will work. But I ordered a turbo drain bung that came with washers and everything. That should seal it up no problem. It looks like that's been leaking anyway. You can see this is the source of the leak right here. I'm gonna see if it fits in that hole. If it doesn't, I'm going to find where this will sit in the car, make sure it's not gonna run into anything, and just drill a hole here and put it in. A lot of people worry about the oil drain backing up and making the turbo smoke and everything, but I have had zero issues using this, and it's well below the oil level line. The reason is it's not under pressure when it's coming out of the turbo. It's just kind of draining passively, and when you use something huge like this, it just kind of drizzles down it, and it'll pull up at the bottom, but I've never had them back up on me. It doesn't push oil through that hard, so we'll just do that. Either use that hole or make a new one up here. All these rockers and push rods were in great shape. I'll just save them for later just in case. I really like how these LTs have the thicker push rods compared to the LS's. They just seem a lot beefier. But we did get new hardened chromoly push rods that we're going to be putting in here once the heads are on. That's the head bolt kit. I think they're in here. Yeah, chromoly 1-piece push rods. I just got the stock length. We'll just double check the valve lash, but generally that is not an issue, especially with a pretty small cam. This stage 1 should be fine. They are hardened, so they should be a little more stout than the stock ones. Anyway, it's coming along good. All right, before I finish buttoning up the engine, I figured I'd better record this. So we've got the dual valve spring kit from Texas Speed. These are titanium. It's got real burly valve seats down at the bottom with the push-on seals. I had some trouble. I damaged the first one trying to push it on too far. They leave a little gap that I didn't like. That's just how they go. So I had to run around a bit to find a replacement one. It was hard to find someone willing to give me just one, but I found one. It's a place called Jack's Cylinder Head in Grantsville, Utah. They hooked me up big time. They just let me have one without paying them, so good guys there. AutoZone, O'Reilly, that type of place, they couldn't even get them for me because it didn't match the 2014 Sierra. It doesn't pop up under their stuff, so I didn't have a part number to give them. So cylinder heads are on, brand new head gaskets. We've got, I usually just put a little bit of copper spray on them anyway, even when they're brand new. So I did that, torqued them down. Interesting thing about these Gen 5s, I already put that valve cover on. There is a, one of the head bolts doesn't match the rest. Let's see if I can show you the old one. So all of them look like this one, except for one on the driver's side has this hex head. And I actually had to run and go grab a 1/2 inch bit for that because I didn't have one that was that exact. So it's 13 millimeter or a 1/2 inch, same exact measurement. So that surprised me. This style of valve spring tool worked great on this LT head. It was actually easier than the last Vortex style truck head, the 317 heads I did. That tool was not optimal for that, but for these it's great. I don't know if you can see on the camera here, but they kind of have goofy angles. They're not perfectly lined up. There's no rail that holds them all together. They're all just individual on their own little stand. So that's pretty cool. Works out pretty good. I used the Right Stuff gasket maker RTV on the front cover and the oil pan. This is the turbo oil drain I came up with right here. This hole is just a little bit too big, so I left the oil level sensor in it, replaced the O-ring so it'd stop leaking. You can see the marks here. There was quite a bit of leakage going on right there, so that's taken care of. Added this bung in, and that's where the turbo will drain, right in there. It's up pretty high and it's not in the way of anything. I measured where the starter was gonna go and it's like way in front of it. And the mount's clear over here, so we should have no problem. That's a great spot for it. I just drilled it out. I just used a stepper bit until it was big enough for my bung to go in. It came with washers with O-rings on them. They're real nice. And so I also just put a little RTV on that rubber O-ring on it on each side, the inner and outer. And that should be perfect for what we're doing here. I almost made a mistake putting the cylinder heads on. I set the one on and then I ran the bolts down, and then I set this head on, and then I realized that this cover here might not fit between these rails without pulling the rails, and I am not going to pull those rails with the injectors out. That's just more trouble than it's worth. So I ended up peeling this one back off, taking the bolts out, putting the center cover back on, and then putting the heads back on and torqued them down. The torque pattern is 59 foot-pounds, and then 90 degrees, and then 60 degrees for all of them, except for that weird Allen head bolt over there. That one goes 59, 90, and then only 40 degrees. While I had it apart, I did end up gapping the rings. That wasn't part of the plan. That's not part of what I quoted originally, but I talked to the owner. I figured since we had the engine out anyway to do all that cam stuff, it was like an extra day of work to get all the pistons and rods out, replace the conrod bolts, gap those rings. The bearings were perfect. I have never seen an LS that had perfect looking brand new bearings in it. This thing has over 100,000 miles on it, I believe. It's been replaced once. So this is actually an LKQ motor. I found the little tag on it right here. It says LKQ, void if removed. If you overheat the engines, these fall off and they won't cover your warranty. But I don't think it was rebuilt. I think it had the original factory bearings and they were perfect. Never seen anything like that in any LS I've ever taken apart. The cam bearings had just a little bit of wear on the bottom, but there's a joke, like in the LS world, you don't look at the cam bearings. If you look at them, they'll be bad. And the reason they say that is because when you look at them, they look horrible. They look like they've worn through to like the copper or brass or whatever is underneath it. But that's just how they all are. They come straight from the factory like that because they would install the bearings and then line bore them. But these ones looked brand new except for the little wear on the bottom. They still had like all the, I don't know what you'd call that, like the ribbing, the machine marks in them. Very impressed with these little motors. I think that there's a lot of potential for them. I mean, we already know it's 2024. These have been around for 10 years. So there's a lot of people pushing thousands of horsepower through the LTs, the LT4s and whatnot. But yeah, very impressed. I'm going to get it in tomorrow morning and start mounting up the turbo stuff.